Hello Rustaceans, welcome to the 18th video of this series. So today we will learn the concept of object-oriented programming. We will also compare this concept and we will uh, write some syntax of the Java programming language because it's majorly or it's commonly known as the object-oriented programming language. We have the most of the programmers work or start the learning of that specific concept with Java programming language. So before moving forward and get deep dive into today's video, we let's just have a recap of our previous video what we have built. We have built the front end with Rust programming language. We have used the Rust library, and we have also we have explored different other frameworks to build the front end with Rust programming. We have compared all of these frameworks. We have uh, compared why we have built our front end in our previous video with the why U takes an edge amongst, let's say, all other frameworks like Leptos, Dioxus, Tauri. So, and also we have covered we have also learned about the different core concepts of front end, like what is DOM. So it's the major concept of the front end. So if you are interested in that front end development, or you have some kind of interest in getting the hands-on on the core concept of Rust or whatever we have learned till now. So you can go and watch this video if you haven't. So let's just get started with today's video. So we will not be starting with the documentation. We will just cover this main chapter, this theoretical paragraph, and then we will take on our previous example of shape. So I will try to implement this specific example of shape, and I will try to explain the concepts of OOP in with simple examples, and I'll try to share less theoretical knowledge, but the most of the concept will be explained through hands-on implementation. So let's say object-oriented programming features. Object-oriented programming, OOP, is a way of modeling programs. Objects as a programmatic concept were introduced in the programming language Simula in the 1960s. Those objects influence Alan Kay's programming architecture, in which objects pass messages to each other. Objects communicate with each other. How, we will get learn about that in a while. To describe this architecture, he coined the term object-oriented programming in 1967. Many competing definitions describe what OOP is, and by some of these definitions, Rust is object-oriented, but by others, it is not. In this chapter, we will explore certain characteristics and that are commonly considered object-oriented and how those characteristics translate to idiomatic Rust. We will then show you how to implement an OOP, object-oriented design pattern, in Rust, and discuss the trade-offs of doing so versus implementing a solution using some of Rust's strengths instead. So let's just go to the next topic, and we have different theoretical knowledge and the implementation with all of these characteristics. So let's just start with the Excalibur and list out the first concept of OOP. So with the name, you get to know about the concept. OOP means object. So means you will have objects, and we have there was a word that object communicates with each other, means there are some of the characteristics, you can say the concept, which means that there are some characteristics with by using that specific characteristics OOP can be implemented on your object. So let's say there are some concept. Let's say first one is abstraction. You cannot number it, but let's just abstraction, encapsulation. You can say you have the concept of. Let me just go. Let's just first implement and explain these two concepts. What are these? So abstraction means, or encapsulation, let's say encapsulation means it's a capsule. It's the word taken from the capsule. What this means, the capsule is the actual medicine or anything will be kept inside that specific, let's say you can say box kind of thing, or you can say the capsule, the all the material will be inside that specific capsule. So same as that, in Rust or in any of the programming, the data will be modeled or bundled, and the parent can share that specific knowledge. So let's us so I have created a project, the library create cargo new, and the project name minus minus lib. So let's just remove everything and let's just create concept. So we have already covered or learned that inside the library create, we the default behavior of Rust is all the structs, methods, functions will be private. We have to make it public by ourselves. So let's say we have a struct kind, let's say shape, and inside that shape we have side as a field of f64, means floating point 64. Now let's say let me create a file named as main.rs, main file. Where why? All right. Inside that file, we can create main function, and inside that main function, let me what I want to do. I want to access that specific shape structure. How can I access? Let me just try with that. Let square is equals to square. No suggestions. But what if make it public? Can I access that? Mhm. No, it's not suggesting me anything. Let's just save it for now and let's just enter. Oh, so let's say square y. Oh, my bad. I have square. It should be square. Why I have written shape. Now square. And what if I want to pass the value of a field? No, side is not. We cannot access the side field. So encapsulation means you can bundle the data and you can. l- So now how can I pass the data inside that field, this side? So we have different implementations for that. So let's just get concept of abstraction here. Let's just create a trade with name shape, and inside that shape we have a function, let's say area, and inside that area we will get the self and return the f64. Same with parameter, we will do 64 of parameter. Let's just save it. And now the abstraction means that you can. So here, encapsulation means to encapsule or to bundle your data inside, let's say anything, or inside your. For with Rust example, you can bundle the struct, and now you can create the implementation of that struct and create, let's say, a function inside that implementation, which will get the input from user, and we can return the value from that function. So now, what's the concept of abstraction? So what this means, so abstract, what the abstract means, the you can say the shared behavior. So what this shared behavior means, so let's say I have encapsule any of the data, and inside that data, what I have to do, let's say I have multiple data with the similar things. Let's say, let's just go back to the code. Let me explain with through this code. So let's say I have a struct rectangle which have, let's say, f60 width of f64. Why I'm using floating point f64? Let's say user wants to pass the sides of values in decimal, so user can pass. Up till now we have only used u32, i32. So I thought to try another type. So let's say f64. Now both of these are shapes. So I have to bound both of these shapes to have some similar functions. Each shape will have area, yes. Each shape will have, let's say, parameter. Yes, they will have. So how we can bind both of these shapes? We can bind it through this state. So let's just implement, let's say, let me just impl, and here you can see the intelligence is saying, let's just impl shape for square for now. Oops, square. And inside that square, let's say, um, here you can see we have a function as area, so self side multiply by 4. Yes, sir. And function perimeter self, my bad, side multiply by side, self by side, or you, and self multiply by side by 4. Here you go. And if you want to implement this shape for square, let's just self dot, let's just rename that width multiply by what's happening with me? And now here, let's just update this as width self multiply by height, and let's just multiply both of them by 2, means width height, width height, so multiplied by 2. So this is, now here you can see there is an error here. Why? We have defined this 2, but we are multiplying it with floating point. So what we have to do, we have to convert it in floating point. Let's just pass the point 0 or double zero, whatever you want. So now the multiplication is between the two similar types of data. The self dot site will be F64 floating point, and this is also the type of F64 here. You can see. Now, this concept can be called as abstract. And the concept here, you can call it as encapsulation. But Hadi, how we can use this square trait? How we can define the value? How we can get the area as parameter, area and parameter? So yeah, here we are. What we can do, we can implement the square, and we can define the functionality inside that specific implementation of the square. So let's say square, and inside that square we will have a function new, and we will get, let's say, side as f64. Let's just don't get the uh, ownership of that specific side. And the new, what we will do, or let us take ownership, whatever, nothing about, worry about that. So let's say square, and inside that square we will define the side. Let's just come add the semicolon here. And now what we have it, we can make it public. Now, instead of accessing this struct, user will just access this new. Does not know what's the implementation of this area, what's the implementation behind parameter, what are different, uh, how we have defined the struct. So we just have to, let's just come here, and what we have is square, and now inside that square what we have, um why I have made it private, let's just make it public. And inside that square we have save it, let's square square, why it's not available, my bad. Let's just make it public, and inside that here square, and in this square we have a function called as name new. So inside new function we can pass the side, let's say 3.0. The side is 3.0. Now what I want to do, each shape will contain the similar functions, area and parameter. So let's say I want to use the function Uh, Now here I have tried to access the functions area and parameter. Both of them are defined inside the implementation and bounded with the trait. So how we can define it? Let's just go back to the Excalibur. So here we have both of these are encapsulation means encapsule the bundle the data, and then the abstraction means to use the shared behavior considered as that. So now what we have defined the struct in the code, we have defined the implementation of the shape, the trait, we have defined the implementation of the struct. However, we cannot access the area and parameter. So how we can do that? How we can do that? We can, because here you can see the return type is empty tuple, you can say there is no value from that specific variable. So how we can get the value of that specific uh, you can say the this struct from that struct. So we haven't returned anything. Where we are here. So now from here let's just return the square struct. Now if you square, and inside that square we will have different into try into, and here we have area. If you want to print the area of, let's say area of square is equals to, we don't have to know, or user don't have to know about what's the implementation inside that area function. User can just use it. If you I want to hover over that specific area, what we have here, um oh, save it. All right. Here you can see no method named area found for struct square in the current scope. Items from traits can only be used if the trait is in scope. Trait shape which provides area is implemented but not in scope. Perhaps you want to import it. Now it is saying that you have to import the trait from this. So let's just import it. Uh, Use lecture 16, and we have shape aspect, and let's just save it, and here you go. Let's just try to print it. Please open the terminal really quick. I'll try to keep this video short so that we um, can cover this concept of OOP easily. And then area of a square is equals to 9, means side multiplied by side. 3 multiplied by 3 is 9. And if I want to print the parameter, you can do that. So now both of these concepts are covered, the characteristics of OOP are covered. Now the third characteristic is inheritance. What this inheritance means, similar concept as inside the tree like architecture. Let's say uh, inside the hierarchy we will have parent will the child and parent, and then after that let's say we will have two nodes. This is parent, let's say, and inside within this parent it is connected to two childs, let's say child 1, child 2. So what does this mean? They are inheriting all the characteristics of this parent. So let's take the example of your family background. So let's say this is your father who is inheriting the genetics characteristics from your grandfather. The grandfather is getting the inheriting the characteristics from someone else, the grandfather, and so on and so forth. The list goes on. So now what does this mean? Let's just go back to the example here where we are. Yes, here. So let's say inheritance means inheriting the characteristic of parent object and implementing my own characteristics as well. Let's say my father is expert in something else, but we I have inherited all the genetics characteristics from him, but he has developed his own skills other than that. And now I am programmer, so I have built my own characteristics as well. So I have developed some skills as inside me. So what in programming language, what we have, let's say I have defined a class. This is the syntax of Java. So let's say I have a class, let's say shape, and inside that shape we can implement anything. Let's say function area. Let's say let's just function area, and inside that function area we can have any implementation. What if I want to same here like that? I have inherited the types here. I haven't inherited the functionality here. Right now I am inheriting the functionality. Now what I can do, let's say class square extends keyword means inheriting. I'm extending the class. I'm the shape. Let's say shape. I will have all the functionalities of shape inside that class. Let's say I can use area here as well. However, I can also define my own functionality in this class as well, in this object as well. I can, let's say, define. L- There are some other concept of overriding, overloading, polymorphism. We will get into it. We will get onto it later on. So let's say I want to define a functionality. Let's say function get site. Let's say I want to return the site. I can do that. So this is what we have in Java. However, Rust does not support this characteristic because you know this characteristic is bounding your view. We don't have enough flexibility in this architecture, in this characteristic. So what does, Rust provides you the characteristic of composition. So what composition means, let me just go back to the Excalibur. So the inheritance means this concept like tree-like architecture, inheriting the characteristics from parent. However, the composition means you can consider composition as like the inheriting the types, or you can bound your struct with your trait. So let's just quickly go back to the example here. Here you can see implementing the shape for rectangle, and we are just defining the functionality of this specific type. Let's say we have defined that each and every shape or each and every struct wherever we will implement this trait will must have this area function and the parameter function. So now let's just go back to the another concept. What we have a concept of polymorphism. So what polymorphism is, let me just go back to this concept here. Polymorphism. And inside that polymorphism, we will have two types: function overloading, and function overriding. Let's just quickly do one thing. Overriding. All right, perfect. So here we are. Let's just quickly go back to the code. So let's say we are let's say we can have an example here. Let's say Java, or let's just consider an example of Java. So what is function overloading, which means, let's say s- inside a class, class square, we will have a same function with different parameters. So let's say we have a function, let's say area, or you can consider shape, and let's say area square, and let's say we have only side one parameter f64, and it will return f64. For now, let's just consider this as a random syntax. Another function we will have, let's say function area of rectangle. Let's say here we have two parameters, width and height. F64, and it will return the same. The implementation will remain same. So function overloading means same the functions will be of same names but with different parameters list. Let's say this is there will be one parameter, but there are two parameters. So we can overload parameters we can overload the functions inside the OOP as well. And override means you can override the functionality of any function. This is pretty much it. And one more thing, these of both of these concepts can be used in Rust, as I have already mentioned that. So let's just go back to the documentation here. There is no consensus in the programming community about what features or language must have to be considered object oriented. Rust is influenced by many programming paradigms, including OOP. For example, we explored the features that came from functional programming in chapter 13. Arguably, OOP languages share certain common characteristics, namely objects, encapsulation, and inheritance. Let's look at what each of those characteristics means and whether Rust supports it. So this is the example of work encapsulation that hides implementation details. What does this mean? That you just have uh, the function behind the scene. The user does not know what's the implementation behind that specific function, what are different fields inside that struct, whatever. So another aspect commonly associated with OOP is the idea of encapsulation, which means that the implementation details of an object aren't accessible to code where we were. Yes, here. Using that object, therefore, the only way to interact with an object is through its public API. Code using the object shouldn't be able to reach into the object's internals and change data or behavior directly. Here we have an example. Here you can see the struct alt. Oops. Let's just come here. So here you can see the public struct, and the struct is marked as public so the other code can use it, but the fields within the struct remain private. This is important in this case because we want to ensure that whenever a value is added or removed from the list, the average is also updated. We do this by implementing add or remove and average. They have implemented three functions: add, remove, and average. Here you can see implemented this struct, and they have defined these three functions. Here, the public methods add, remove, and average are the only ways to access or modify data in an instance of average collection. They have here uh, we have created an instance over here. We can create another instance right next to next line inside. We can create, let's say, another instance with some other value. The functionality will be different. The base functionality will remain same, but the value and the result will be different. So let's say 4.0, and the outcome will be 4 multiplied by 4, 16. The area will become 16. So now let's just, when an item is added to list using the add method or removed using the remove method, the implementations of each call the private update average method that handles updating the average field as well. So this is pretty much the explanation of the same content, the same concept with uh, a slightly different example, you can say. Cool, I guess it's pretty much clear for you. If you don't get it, so let's move your progress bar slightly previous. Inheritance as a type system and as code sharing. Now we have a concept of inheritance. Inheritance is a mechanism whereby an object can inherit elements from another object's definition, thus gaining the parent object's data and behavior without you having to define them again. If a language must have inheritance to be object oriented, then Rust is not such a language. There is no way to define a struct that inherits the parent struct's fields and methods implementation without using a macro. We will learn about macro later on, but as I mentioned that there is no concept of inheritance or the you cannot use inheritance with the structs. I have just shared an example with you. So of let's say the example of the abstraction characteristics. You can apply the abstraction and you can consider uh, the inheritance like that, like implementing the trait. This is not the similar concept, but the same concept, but it is slightly or some kind of similar with that. Now here, however, if you are used to having inheritance in your programming toolbox, you can use other solutions in Rust depending on your reason for reaching for inheritance in the first place. Here they are mentioning that when we added a default implementation of the summarize method on the summary trait, any type implementing summary trait would have the summarize method available on it without any further code. This is similar to a parent class having an implementation of method and inheriting a child class. Parent and inheriting a child class, also having the implementation of the method. We can also override the default implementation of the summarize method when we implement the summary trait, which is similar to a child class overriding and the implementation of a method inherited from a parent class. So this is polymorphism. To many people, polymorphism synonymous to, let's say, inheritance or synonym to inheritance, but it's actually a more general concept that refers to code that can work with data of multiple types. For inheritance, those types are generally subclasses. Rust instead uses generics to abstract over different possible types and traits bounds to impose constraints on what those types must provide. This is sometimes called bounded parametric polymorphism. So let's say if you don't want to define any specific type, you can just use the generic parameter, let's say angle bracket, and within that angle bracket, you can pass the any of the alphabet or character. So it will be considered as the generic type. Inheritance has recently fallen out of favor as a programming design solution in many programming languages because it's often at a risk of sharing more code than necessary. Subclasses shouldn't always share all characteristics of their parent class, but will do so with inheritance. And this is pretty much it. If you want to get deep dive much more into that, I will share a great resource with you in a while. So you can go over that specific documentation. This will help you understand the concept of OOP with the Java programming language, the syntax of that specific. Using trait objects that allow for values of different types. Here, let me just we mentioned that one limitation of vectors is that they can store elements of only one type. We created a workaround in whatever where we defined a spreadsheet set enum that had variants to hold integers, floats, and text. So let's just defining a trait for common behavior. We have already covered that. So they have created a trait called as draw and screen, and we have implementation of that screen struct screen. They have implemented a generic. Here this works differently from defining a struct that uses a generic type parameter with trait bound. With trait bounds, a generic type parameter can be substituted with only one concrete type at a time, whereas trait objects allow for multiple concrete types to fill in for the trait object at runtime. For example, we could have defined the screen struct using a generic type and a trait bound as in listing chapter 80. So here we have the trait bound. This is called as this generic, but it is bounded with the draw. It is a trait. And here we, we can use this syntax to bound this specific generic with the trait. It's called as the trait bound concept. Implementing the trait, you can implement a trait here. You can go with that. It's pretty much simple concept. You can work with that easily. Here we also have a concept. Let's say if I want to, let's say if I want to define let's say vector squares, let's say like that. And inside that square, let's say I have a vector here, vector and square, let's say square 2. We can create a square 3 here, 5.0 square underscore 3. And how we can iterate over there? So let's say for, let's just work with for loop. Let's say I or index and shape, let's say, and square, square, vector squares, sorry, vector squares dot. And after this dot, you can explore that. Let's say iterate over all these vectors, and I want to enumerate to get the index as usize and shape as a square struct. And let's say I want to print the area of each of the squares. So let's say print the area of, let's say, shape number, let's say number index, and is equals to, let's say, area, and define the shape. Click shape dot area, and let's just print it. Let's try to run the code. Cargo run. Area of a square is equals to 9. Area of number 0, 9. Number 1, 16. Number 2, 25. What if I convert or add it inside the box? Oh, okay. Oops. Let's just quickly add closing parenthesis here, here, and here. Let's just save it. Oops. Save it, save it, save it. And let's just run the code. The code will run perfectly fine. Now let's just understand what they are saying here. So here they have created a vector box new convert pass in a smart pointer, and they are screen dot run. They have a function run and they are running that. However, the trade draw is not implemented for string. There is no implementation of that specific string. So now let's say where we are. Why it's not opening? All right. So let's say we can add a dynamic shape here, or let's say create a rectangle here. We have added the same functionality inside the rectangle. Yes, it's fine. Public struct. Perfect. Let's just save it, and let's just rectangle, import the rectangle, rectangle, let's say 5 and 1. And in this vector rectangle, let's just save it. Now, v- previously we had the box square. Now we have passed the diff. Oops, rectangle, new. Oops, we haven't implemented this. So let's just quickly implement the rectangle width and height will be f64, width and height. Save it really quick, and let's just come here. Here you can see mismatch types expected struct box square found struct. We were expecting the type as a square, but here we have passed the rectangle. So what I want to do, I want to just pass that. Let's say the vector will be of type square. Oh, sorry, square shape. Let's just save it. One more thing here. because you can add the dynamic keyword if you want a trade object. If you want to pass the trade object inside that box, you have to pass the dynamic keyword. Have passed the or you can say the dynamic. And if I want to rerun the code here, the code is written instead of shape. Yes, shape number one. Shape area of shape number one, the shape number 0, 9, 16, 25, and 5 multiplied by 1. So here you go. So it's you can consider this thing concept of polymorphism, same as they did here. Where if we have, yes, here. So they are, this can be considered as a concept of polymorphism. Recall in performance of code in general in chapter 10, or our discussion on the monomorphization process is performed on generics by the compiler. The compiler generates non-generic implementations of functions and methods for each concrete type that we use in place. So vector will consider the first value as its type. So I have passed the first value of type square. So the Rust considered that I will pass all the values inside this specific vector of type square. However, I didn't mean to use that. I was thinking of creating a vector with different shapes, but they will have a trade bound of shape trade, and we have to use the dynamic keyword inside that specific type declaration. So here, this is pretty much it from this chapter, subchapter, chapter 18.2. So cool is that? Yes, sir. Let's just move to the next chapter, 18.3, implementing an object-oriented design pattern. So the state pattern is an object-oriented design pattern. The crux of the pattern is that we define a set of states as a value. A value can have internally. The states are represented by a set of state objects, and the value's behavior changes based on its state. We are going to work through an example of a blog post struct that has a field to hold its state, which will be a state object from the set draft, review, or published. Let's just review this. The advantage of using the state pattern is that when the business requirements of the program change, we won't need to change the code of the value holding the state or the code that uses the value. We will only need to update the code inside one of the state objects to change its rule, or perhaps add more state objects. Here you go. Post new, they have created a new post, pass the add text, pass the text inside that. Now defining post and creating a new instance in the draft they have created. They are implementing the same implementation with different examples. I have, because I thought that the example of shapes is pretty much easy for to understand for you. So I have taken on that specific example up till now. So let's say a pub struct post implementation of that specific struct. They have declared the states as a trade, struct draft, and implementing the state of for draft, sorting the text and they are working with the same. So what they mean that if I want to change the implementation, there is any change inside, let's say a function, what we have to do, we just have to go inside this that specific file or library create. We can just update the functionality, and it will be reflected over all over the files in Rust program. We just have to update once, and it will be reflected all over the places. So now they are for function content, and so they are explaining all of these implementation. Why not an enum? Why we haven't used enum, instead we are using the struct. You may have been wondering why we didn't use an enum with the different possible post states as variants. That's certainly a possible solution. Try it and compare the end results to see which you'd prefer. One disadvantage of using an enum is that every place that checks the value of the enum will need a match expression or similar to handle every possible variant. What does this mean? So let's say um let's say status, can define the status value here. So let's say, well, I can define the status value as, let's say, pending, whatever. However, I have to pass the new, we can, let's say, uh, create the implementation of the, let's say, status struct here, and we can define all the values here, and it will be saved inside that specific struct, and we can reuse it. However, with enums, we must have to use the match expressions all over the place. Let's say I want to compare, let's say, whether m- match, let's say, enum well, whatever enum I have created, let's say well, or let's say match enum status, and inside that status we can match, let's say, the status colon new, oh sorry, pending, and so on and so forth. So we have to use the match expression all over the places that we don't want. So trade-offs that of the state pattern, we have shown that Rust is capable of implementing the object-oriented state pattern to encapsulate the different kinds of behavior a post should have in each state. The methods on post know nothing about the various behaviors. The way we organize the code, we have to look in only one place to know the different ways our published posts can behave. The implementation of the state rate on the publish struct. Now everything is here. You can read this documentation from this 18.3 chapter. So this is the link here. So encoding states and behavior as types, you can encode that as types. Let's say um, content. So draft pose, you can create a separate implementation for a draft pose. You, you can distribute, or you can divide every implementation on its own struct and with its own implementation. Let's say have a pending post, so I can create a separate struct for that instead of creating a post. So you can do that. There's no need of specifying each and every example. So let's just read a summary regardless, or before reading this summary, let's just get this documentation here, blog post. What this article have, this has all these object-oriented programming languages concepts. So a big difference between OOP and non-OOP is that an object should expose behavior and hide most or all of its data. Concept can be called as encapsulation. Yes. So Java defines OOP concepts as follows: abstraction, encapsulation, inheritance, polymorphism. There is another characteristics: method overloading, method overriding, and there is another thing: shadowing. So let's benefits of inheritance, reusability, polymorphism, flexibility, and you can read over this documentation, or you can say the article, blog post, where you can see the examples of Java. So this is pretty much it. How cool is that, by the way? Yes, sir. Let's say the summary, regardless of whether you think Rust is an object-oriented language, after reading this chapter, that you can use trade objects to get some object-oriented features in Rust. Dynamic dispatch can give your code some flexibility in exchange for a bit of runtime performance. You can use this flexibility to implement object-oriented patterns that can help your code's maintainability. Rust also has other features like ownership. Ownership is here as well. That object-oriented languages don't have. An object-oriented pattern won't always be the best way to take advantage of Rust's strengths, but it is an available option. Next, we will look at patterns, which are another of Rust's features that enable lots of flexibility. We have looked at them briefly throughout the book, but haven't seen their full capability yet. Let's go. So we have already worked with pattern matching, like we have used the match keyword, the match expression. We have also used the if else statements, the conditional blocks. So as they have mentioned that we will get deep dive into all these concepts, so let's just understand or learn all these concepts in detail in upcoming video, in the next video. So I hope you have learned a lot of stuff from this video. If you have any queries, just let me know. Just drop your queries in comment box, or you can reach out to me through on my socials or LinkedIn. So I haven't shared any post about the front-end programming front-end development with us. I'll share it today. So you will see the explanation of that specific LinkedIn post in next video. And that's pretty much it from today's video from my side. And if there is anything from your side, if you have any suggestions, feedback, you can just share it with me, and I would love to consider your feedbacks. And this is pretty much it. So till the next video, bye and be productive.